All right, so we just did a little molarity and molality calculation. Mole fraction again is extremely easy. I think. Well, it's extreme. It's the more of the. It's the more of the. It's an easier of the three concentration calculations, I think. Mole fraction, ethylene glycol. Here's an example. Ethylene glycol is added to an automotive cooling. It's engine coolant to protect against cold weather. What is the mole fraction? So we're looking for the mole fraction of each component in the solution containing 1.25 moles of ethylene glycol, I'll put EG, and 4.00 moles of water. Okay? The mole fraction is basically the, I'll write it down, is the moles over the total moles. Or in other words, 1.25 over 5.25. Because when you add these two up, you get 5.25. And 4.00 over 5.25. All right? So 1.25 divided by 5.25, 0.24. And there is no units, it's just 0.24 is the mole fraction for ethylene glycol. I can divide 4.0 divided by 5.25 to get the other one. I know I'm going to get 0.76. I wouldn't have even had it to divide because the mole fractions added up are always 1. Okay, so there may be times where I give you 3 mole fractions and I say there's a 4th component of that solution. What's the mole fraction? Well, you just add the 3 of them up, subtract from 1, and you'd get the 4th one. Okay, because the mole fractions always add up to 1. And again, that's because we're not multiplying by 100 to get percentage, just a fraction. Okay, so there's your mole fraction. Moving right along. Colligative properties. Colligative properties are when you have a solution, the property of the solvent changes. So when you have a solution, the property of a solvent changes. So property of a substance change because you add a solute. So here are some examples. Here's some colligative properties. Boiling point elevation. The boiling point will always go up when you add a solute to a solvent, okay? So water boils at 100 degrees Celsius. If we put salt in that water, it's going to increase the boiling point. Always increase. It's always an elevation, okay? Now, depending on how much we put will determine how much the elevation goes up, okay? And so boiling point elevation, colligative property, its formula is, and there's an actual formula that you can calculate, is the change in temperature of the boiling. So again, that would have been that increase right here. The change in temperature of the boiling is equal to the KB, and the KB is the boiling point elevation constant. It's not constant for everything. It's constant for whatever the solvent is. So water has a KB. Ethanol has a KB. Formic acid has a KB. And so if you were putting something in any of those different solvents, then they would go up depending on what the molarity is. Because it's the KB times the molality. Molality. All right? So obviously the higher the concentration, or in other words, the higher the molality, you multiply it by a constant, you're going to get a higher elevation in boiling point. All right, so that's your boiling point elevation. Another colligative property is freezing point depression. Freezing point depression, same deal, same formula pretty much, except for the freezing point always depresses. It always drops when you add a solute to a solvent. All right, And again, the Kf is the freezing point depression constant. It's not the same, again, for every solvent, and it's not the same as the boiling point. But just know this is the important thing to recognize about boiling and freezing point depression, boiling point elevation and freezing point depression. If water freezes at 0, freezing point, and the boiling point is 100, if the boiling point elevates and the freezing point depresses, then what you're looking at is you're going to have a longer or a larger range where the substance is a liquid, right? If you're elevating your boiling point and you're depressing your freezing point, then your substance is going to be a liquid longer. Again, antifreeze, just as the example, ethylene glycol is coolant. Antifreeze, it's also coolant. You put it in your engine, you put it in your vehicles so that it elevates the boiling point so that your car won't overheat, and it depresses the freezing point so that your liquid in your radiator won't freeze. So it extends how long the substance is going to be a liquid. The formula is straightforward. It's the change in temperature. The change is going to be the freezing point constant or boiling point constant times the molality. Now I do want you to notice this. Let me grab a color again here. Excuse me. Notice that you're going to be calculating for the change. So if you ask for the change in boiling point, if you get 5 degrees Celsius, then that means your new boiling point would be 105. All right? And if you get a change in temperature of 8 degrees Celsius, it's going to be positive. It's always going to be a positive value, but it always depresses. So in the case of water, it would depress, and so your new freezing point would be -8. All right? Now, if it's a substance that had a freezing point of not 0, but rather 40, and your change in temperature was 8, then you would get a 32 degrees Celsius freezing point. Again, it always depresses. You would just subtract. You're not going to get a negative value. It's always going to be positive, but just know that it depresses from those freezing points. So that's boiling point and freezing point depression.